Okay, so what I'm going to teach you today is in section 2.3, and we're going to learn about Descartes. Bless you. We're going to learn about Descartes' rule of signs. Did we do this yesterday? No? Okay. We were kind of trying to work on our inner right pad and the new stuff, but anyway, thank y'all for helping me. Descartes' rule of signs. Now, here's what Descartes' rule of signs says. It says the number of positive real zeros or roots, let's put roots, is equal to the number of sign changes in f of x. Okay? Let's write this underneath it. Or lesser by an even number. And I'll explain to you what that means. That's not hard, okay? And the number of negative real roots is equal to the number of sign changes in f of negative x, or lesser by an even number. Okay? So let's talk about what this means for us. If I give you a polynomial, f of x, let's say 2x to the third minus 4x squared minus x plus 7. Okay? Now, let's pretend like we're doing the little 50-point test, right? What's the number of solutions that this thing has? How do you know that? The highest degree. The highest exponent is the degree of the polynomial. What if I asked you to list the possible rational roots? Could you do that?
Yeah.
Okay. So, tell me how to do that. Plus or minus p over q, and who is p? 7 over the leading coefficient 2. It's always the factors of a constant over the factors of the leading coefficient. So, plus or minus. What are the factors of 7? What are the factors of 2? Okay. So, will I accept an answer like this? No. You have to rewrite it. You have to put all of these over 1. That's just plus or minus 1 and 7. And then you have to put them all over 2. That's 1/2 and 7/2. Okay. And then you would find f of 1 and f of negative 1, right? See if you could find a 0. I made this up, so we're not doing it because there's no telling. They're probably horrible. All right? But anyway, there's another thing that you can use, and it is Descartes' rule of signs. And this is the chart that we use to do and show Descartes' rule of signs. Positives, the negatives, and the imaginaries. Those are the 3 types of roots that you can have. Positive roots, negative roots, or imaginary roots. Alright, so if I want to know the number of positive roots, I'm just going to do what that thing told me to do. It said, count the sign changes in f of x. Well, here's f of x, guys. So I'm going to count the sign changes. This first term is what? Positive. So from positive to negative, there's 1. To negative, no. To positive, so there are 2. Alright. Now, let's talk about that little word that it says underneath it where it says, or lesser by an even number. That has to do with these imaginary roots. Where do imaginary roots come in? Pairs. Conjugate pairs. Okay? Now, later on in like section 5, they're going to give you the roots to the polynomial and say, hey, here's the roots. You write the polynomial. Okay? And see, one of the things that they'll do sometimes is they'll say, hey, 1 plus 2i is a root. But they won't tell you the other one, but they expect you to know it. Because if 1 plus 2i is a root, what? 1 minus 2i is a root, because they're conjugate pairs. Okay? They're conjugate pairs. All right. So these numbers only come in pairs. What's a pair? How many are in a pair? 2. When you open up your pair of shoes in the box, there's only 2 of them in there. 3 come in there, and you go, whoa, wait. Somebody's going to be unhappy when they open up their box, right? Because they only got 1. So all the numbers in this column should be what kind of numbers? Tell me examples. 2, 4, 6, 8, 0, anything like that. Okay, so that's why we take this, we find this number, and then you subtract 2 until you can't subtract 2 anymore. That 2 stands for those pairs of imaginaries. Okay, can I take 2 from 2? So there are 2 positives, or there are 0 positives. 2 minus 2 is 0. Okay, now let's find, you find this number, and then you subtract 2 from it until you can't subtract 2 anymore. Because those represent the imaginary roots that you could have. Okay? And they come in pairs. So there's either going to be 2 of them, or 4, or 6. And if I take 2 away from, like, let's pretend I started with 7. What's 7 minus 2?
5.
What's 5 minus 2? What's 3 minus 2? So there are 7 and no imaginaries, or there are 5 and 2 imaginaries, or there are 3 and 4 imaginaries. You see what I'm saying? Okay, well, we're going to do that in a minute. Okay, but that's what I was explaining. All right, let's do the negative one. The negatives is the number of sign changes in f of negative x. Well, guys, f of negative x, all he's going to do is change the sign of every term that has an odd exponent, okay? So this guy has an odd exponent. I'm going to change his sign. Okay? This guy doesn't have an odd exponent. Don't change his sign. All right? This guy has an odd exponent, so I'm going to change his sign. People, he doesn't have an x. You can't change his sign. He's constantly 7. It's all he ever is. He never gets to be anything else. Okay? Now here's a mistake that some of the kids used to make. They would count the sign changes from here to here. That's not what it said, did it? It said count the sign changes in f of negative x. So how many sign changes here? 1. Can I take 2 from 1? Then there's 1. That's it, people. There's 1. Okay? Now, here's where the fun starts. Alright? Let's pretend these are the guys and these are the girls. Every guy has to dance with every girl. Even if she's ugly. They got to dance with her. Okay? Alright. So, 2 dances with 1, and what? 0's got to dance with 1 also. Well, what about these imaginary roots? These are my fillers, okay? They're what I need to make 3 across, all right? 2 and 1 make 3, so how many imaginaries do I need? 0 and 1 make 1, so how many imaginaries do I need? Very good. Okay? Now listen to me. Can I ever put these numbers in this column? No. That's a common mistake that kids make, especially in Algebra 2. They'll do this, and then they'll pull these and put them over here, and pull these and put them over here. And I'm like, people, these are guys. You can't put them in the girl column. These are girls. You can't put them in the guy column. Okay? Guys got to stay over here. Girls got to stay over here. Everybody got it? Okay, so let's try 1 more, 2 more, and then I'll give you a problem to work. Okay? So, let's do one like this.
You don't have to add in like x squared, x cubed,
Mm-mm.
like if they want.
If they're not there, don't. Okay, I'm going to show you something. I'm going to show you how this tool, because remember what I told you. I said this is just a tool for your toolbox, people. Sometimes it's helpful. Sometimes we'll use it. I'm going to ask you to find it, okay? And sometimes it's useful and sometimes it's not, okay? So let me show you where this one would be useful. Matter of fact, let's just change this last number right here to an 18, okay? Now, can you find the possible rational roots? Yes or no? Okay, so let's find them really quick. So plus or minus P over Q, right? So the last are first and the first are last. So it's plus or minus the factors of 18 over 3. Do I want to reduce this? No. Don't reduce it, people. You knocked out a whole bunch of possibilities. Okay? So plus or minus. The factors of 18, 1 and 18. 2 and 9. 3 and 6. 4 and nothing, 5 and nothing. Factors of 3 are 1 and 3. Will I accept your answer like this? No. You got to put it in there. All right? So I'm going to put all these numbers over 1. Well, don't forget the plus or minus, guys. That's just all those numbers. Okay? Now I have to put all these numbers over 3. So it's 1 over 3. 2 over 3. What about 3 over 3? That's 1. What about 6 over 3? Got it. 9 over 3. 18 over 3. So that's it. Okay? Now let's do Descartes' rule of signs. So, how do I figure out how many positive roots I'm going to... The number of sign changes in f of x. Look at that, people. How many sign changes? 0. So what do I do with that number? I take 2 from it until you can't take 2 from it anymore. Okay? You always think about that. I'm going to write it down, and then I'm going to subtract 2 until I can't subtract 2 anymore. Can I take 2 from 0? What did I just do to these possible rational roots? You cut all the what? Yeah. You cut the number in half, people. It used to be I had 1, 2, 3, 4, 5, 6, 7, 8, 16 possibilities because of the positives and negatives. And now, guess what? I got 8. That's good. That's really good. Am I going to try 1? No, people. It's not going to work. There are no positive roots. Am I going to try 2 or 3? No, they're not going to work. Okay? All right, so what about negatives? You find the number of negative ones. Okay, so what we did was we found f of negative x. All I did was I went up here. Anybody that had an odd exponent, I had to change the sign. So I kept the sign, changed the sign. Kept the sign, changed the sign. Always keep the constant sign. Now when I count the sign changes, what do I get? Okay, so there are 4, or. Now, what do I have to do over here? You just got to pull those zeros. Y'all, it is 0. There can't be nothing else. You can't, like, make something up and say, well, I don't like it to have 1, so I think I'll pick 3. No. It's just there are no positive roots. Okay? What am I trying to make? 4, right there. 0 and 4 make 4. How many imaginaries? 0 and 2 make 2. How many imaginaries? 0 and 0 make 0. How many imaginaries? 4. All right, y'all remember doing this last year? Yes. Okay. All right. So let's, this one I'm going to give you one more before you do your problem, all right? And I want you to, I'm going to do it a little bit differently. Instead of writing an equation for you, I'm just going to tell you that it's a 7th degree polynomial. Okay? That's what I'm going to tell you. And I'm going to tell you that I counted the sign changes. Oh, no. And there were 4 positive sign changes in f of x, and there were 3 sign changes in f of negative x. So you complete the chart. It doesn't matter. All I want you to do is just complete the chart. So the leading coefficient doesn't affect it.
So if you can't subtract 2 from it, so it's 2 down to 1.
Well, then you only have 2 choices during one.
Going back to what Zach said, you can't subtract 2 and then normally just bring it down.
Well, you subtract, remember what I said, you subtract 2 until you can't subtract 2 anymore, okay? So then that gives you your possibilities. And then what do you have to do? You got to go back and make sure that every guy in the plus column gets matched up with every girl in the minus column, okay?
So we only get this type of question on the 50-point test, and we have to fill it out.
You're going to have to do all, yeah. And that's what I'm fixing to do. When we get through doing this, then I'm going to give you one equation, and I'm going to tell you everything that I expect you to do for the 50-point test. And then I'll let you practice it for the rest of the class period. And then Monday we'll talk about it. If we have time Monday, we'll teach something else. If we don't, we won't. If we need to practice another one, we'll practice another one. Your 50-point test is going to be Wednesday. Okay? So, no, we have another 100-point test. Yeah. But we still have some other stuff. We've got to do complex numbers. That's the I's.
Oh, okay.
Okay? And then we have a few other things to do. Some of it we've already done. So 50-point test and maybe 2 big tests. Maybe 2, maybe just 1. Yeah, well, it's a long 6 weeks.
Yeah, and then I don't understand why they don't put the 7th week at the very end of the school year, because then exam week's not really a week.
Yeah. I'm recording the phone. You'd think if kids could figure that out, they could too. Yeah. Okay, so I'm going to subtract 2 until I can't subtract 2. So 4 or 2 or 0. Subtract 2 until I can't. 3 or 1. Now here seems to be the part that kids get all mixed up on. I don't understand it. Because really, y'all, it's just what I said it is. 4 has to be matched with every number in this column. So I've already matched him with 3. Who have I not matched him with? So I'll put him with 1. I'm not 2-ing yet. So now, what does 2 have to do? He has to get matched with everybody. He's only been matched with the 1, so who do I need to match him with? 3. Alright? 0 has to get matched with everybody. People, I haven't matched him with anybody. Who do you want to put him with? Okay, would it matter? No, you just put one. One of them you do here, and the other one you go right here. I pick 3, and then I'd put him with 1. Okay? Now it's you're going to use your fillers. I'm trying to make 7. 4 and 3 make 7. I don't need any. 2 and 1 makes 3. Gotta have 4. 0 and 3 make 3. Still need 4. 4 and 1 make 5. Now, y'all listen to me. If I start adding these things and I need a 5 over here, what do I know? You messed up somewhere. You better go figure out what the problem is. But you got a problem because these should only be even numbers. Okay? So, 4 and 1 make 5, so I need 2. 2 and 3 make 5, so I need 2. 0 and 1 make 1, so I need 6. Okay, anybody got a question? Everybody understand that? Okay, that's Descartes' rule of signs. So let's do a little practice 50-point test. Here's your polynomial. Now, what are you not going to get to use on the 50-point test? A calculator. And I'm going to tell you right now, the most difficult thing on the 50-point test is going to be graphing. And I'll show you why. Okay? I'll show you why. So here's my problem. 2x to the 4th plus 7x to the 3rd minus 4x squared minus 27x minus 18. The first thing I'm going to ask you is, can you tell me the number of solutions? The next thing I'm going to ask you is, can you tell me the possible rational roots? Then I'm going to ask you, can you fill out Descartes' rule of signs? Then I'm going to say, can you find the zeros of this polynomial? And can you list the factors of this polynomial? And then I'm going to want you to graph it. Okay, so can we just pretend for a second? Yes? Yes? All right. So I'm going to just pretend something. I want to show you what I expect from your graph. Okay? All right. Here's what I expect from your graph. Let's pretend that we got my zeros. How many zeros am I going to get? You're going to get 4. I was very specific in the problems that I picked out for you and everything, so they're not going to have imaginary roots, all right? Or this one doesn't. So let's say that I got -2 and -6 and 1 and 3/2. Okay? So watch. -6, 1, 2, 3, 4, 5, 6. -2, 1, and 3/2. He's going to cause a problem. Alright? So, my T-chart. Now, let's see what I know. Well, it's a 4th degree equation. What does that tell me about his beginning and ending behavior? They go the same way. His leading coefficient is positive, so what does that tell me? Yeah, so this one's going to go up, and this one's going to go up. Now, y'all look, I don't have a calculator, so this is just a sketch. Okay? What do I want to know in here? Yeah, how far does that thing come down? So I'm picking me a point in the middle of it, right? Looks like it might be what? -4? I'm going to plug it back in that equation, and I'm going to see what I get over here. I'm going to plot that point. Okay? Look here. Between these two right here. People. 0. What you going to get at 0? -18. If this was a problem, that's what you get. Okay? I made those up. Those aren't right. Okay? Why is this one going to cause me a problem? Because guess what I'm going to pick between 1 and 1 1/2? 1 1/4, which is 5/4. Now, is he going to be fun to put in here? He's not, people, and I know that, okay? But you're just going to need to do the best you can, okay? You're just going to need to do the best you can. All right, and if that's all you mess up on is one little crazy point, you'll lose some points. You may not make a 50 out of 50, but you'll be okay. Yeah, those aren't really the answers, but that's why graphing's the hardest. Okay, yeah.
English A.
Actually, on that one, you'll have to raise it to the fourth power. It'd be 625 over 5/4. So over 250, no, 625. What's 16 squared? 256? So it'd be 625 over 256. Crazy, I know.
So for the P over Q, we're just doing 18 over 2.
Do what?
So
Here.
for P over Q, so it says 18 over 2.
Mm-hmm. Factors of 18 over the factors of 2. Yeah. Okay, so there's your problem. That's what I want you to work on the rest of the class period. Okay? And then Monday, we'll talk about it. Uh-huh.